All right, Cecil, go ahead.
Well, first of all, I'd like to thank Jim for his continuing support. KI6ZUM, I asked him to share his experiences with the Papa system. I still recall the day that Jim and I and Art went up to set up the first ICOM D-Star radio that wasn't an ICOM, that Art and Jim and myself put together, and it operated flawlessly for about 15 years till we upgraded it to MTR 2000. But it's just part of the Papa family that we have so many people like Jim that makes the Papa system simply the best and keeps it on the leading edge. And I just want to thank the membership that is listening today for all their help. And there's just so many people in the system that have the positive mental attitude and can do. They look at a problem and they help resolve it. And if you think of it, the astronomical challenge of keeping 68 repeaters functional. And if I look at the list today, we've got an issue with a couple, but a couple out of 68 isn't too bad for an amateur group. And again, I want to thank the membership, and I want to thank Jim for sharing the history on his efforts to keep amateur radio on the leading edge here with the Papa system. Jim, I guess it's your turn in the barrel. KI6ZUM, thank you for doing your presentation. Looking forward to it.
All right, thank you, Cecil and Michael. Let me see if the sharing is still working. Checked it beforehand. So Cecil asked me to do a presentation to talk about some of the history around the non-ICOM, starting back with the non-ICOM repeaters. And I said, well, I've got these presentations that I typically do at conventions like PacificCon and so on. So I modified it to cover what we're doing now and giving a bunch of history of where we came from all of this stuff we're doing in open source, more specifically from open source. Want to talk firstly about the earliest stuff that we did. Cecil talked about it briefly, about the D9 repeater that we put up. Later, things like MMDVM, Pi-Star modes, and more modes. I want to cover a few of the hardware devices that have been produced. There's just so many that we can't even, we'd spend a couple hours just going through them. And there's been a bunch of new things going on in open source, not necessarily exactly related to a repeater, but I wanted to kind of talk about them and give you guys a head up, because that's kind of what it's been like all along, that the Papa system tends to hear first, more or less. Every new product, Papa system members hear about it before anybody else in the world. So a huge chunk of what I do is based on the idea that the source code is made available to the public. The public can use that source code following the license terms. For the most part, we use GPL, which is the GNU public license. I like it as a license better than, say, MIT or Debian or any of the other ones. And Jonathan Naylor, G4KLX, also uses GPL. Basically says you can use the source code if you want, you can make changes if you want. If you do make changes, you need to make available those changes to the public. And that's about it. And that's been a huge part of how MMDVM has become so successful. There's also some hardware licenses available that are a little different because hardware is different than software. So many of my products also come with an open source hardware license, and in this case, I use Creative Commons. When we talk about open source, people often say that it's patent-free. That's not typically the case. If it's open source, it just means that the person who developed it is not asserting any patent rights, but it doesn't mean that other people might not have already, that other people could have already invented it before and patented it. So it's not necessarily patent-free, and you need to be careful with that. And then trademarks are very different than patents or copyright. We have not been big enough to do any trademarking of MMDVM. It's kind of expensive, and especially if you do it for a lot of countries, and being an open source project, we just haven't had that luxury. So the early history, I'm going to talk first about D-Star because it's the first of the digital modes that became successful. There was some digital stuff done before, but it was more experimental. So this is based on the work that the Japanese Amateur Radio League did to develop the D-Star spec. And shortly thereafter, Mo Wheatley, Robin Cutshaw, and Satoshi Yaguden, I think his last name is, did a lot of really cool stuff. So we can talk about August 2005. You know, we're almost 20 years past the release of the D-Star spec, which means they were started on this almost exactly 20 years ago. And the 2005 version is the translated one, so the Japanese was a little predating for that. Everything you need to know to create a D-Star repeater is contained in this spec. Some people talk about D-Star being closed source. The spec is not closed source. It's been available for a very long time. Everything is detailed. Everything is there. What's not available to the public is the audio compression and decompression, which is done with the AMBE chip. But for the repeaters and all the stuff we've been doing in the open source based, we don't need to do the audio compression decompression, so we can make use of these specs and come up with really cool devices. Now, here's a post from Satoshi in 2007, where he said he took the 7021 eval board from ADI and was able to get some basic bits of a hotspot going. So this is like the earliest ideas of the Zoom spot and other hotspots came the genesis for. We all have to give credit back to Satoshi for doing this work. And that's back in 2007. Satoshi also made the node adapter, which is the basis for a lot of the work that was done early on for D-Star repeaters, such as the repeater we put on D9 up in San Marcos. These are based on the 589 chip from CML, which is the chip that does the modulation and demodulation. So it's the GMSK modulation. If you look at this board, this is one of the very earliest ones. I'm not sure if you can see my mouse while I'm pointing, but down here is the analog interface circuit. So it's basically one op amp in each direction, one for transmit and one for receive. In a little bit, you'll get to see the most current version of the radio interface boards. The analog circuitry has evolved greatly, given almost 20 years of feedback and testing from the ham community. And early on, even though Satoshi said do not copy, he still published his schematics. And so he was doing a lot of open source stuff early on and publishing and sharing. And you can see down here that it's dated 2008. So it's pretty early on. Next, we've got Mo Wheatley. This is Mo's D-Star, his D-Star hotspot, in that it used the AMBE 2000 family chip and a 7021 chip to be able to do D-Star with a computer and a microphone. And so he never got it to work very well, which is unfortunate. He put a lot of time and effort into it. Turned out there were some minor mistakes in what he had done, and if he'd ever caught them, he would have had a really cool product. Many of you are familiar with Mo's later product from 2010, which is the DVAP, and this is the early version. Again, it's based on the 7021 chip. The processor that he used is a pretty beefy processor, works pretty well for what they did. If he had used a higher quality oscillator than the one that he has here, it's entirely possible he could have added DMR and Fusion P25 and NXDN to the DVAP, but unfortunately he did not use the higher accuracy part, and it's not really feasible to do, as far as I understand, it's not feasible to do those other modes in the hotspot. This is the one that Cecil was talking about. I could not find a picture of the board anywhere. I could find only this rendering of a board that was similar to it. But this is essentially what we put up on the Hilltop in San Marcos. It's using the same modulator demodulator chip. It's still using the same circuitry for a single op amp in each direction. It's got the same PIC controller that Satoshi is using, and we got these PCB layouts. I got the PCB's board. We built up, I think we did a whole bunch for members in the club. I forget how many. We got it all set up to put on the Hilltop. And I do remember the day very clearly, as well as Cecil does, because it was Super Sunday and we had to get it done and back down the Hilltop before the game started. I have to call out some specific Papa members here. I am missing names here. I could not remember everything, but I felt it was important to have a single slide to talk about people who have helped develop, test, give feedback, offer suggestions, give constructive criticism, request features, especially in the early days. People like Ted, Dave, and the other Dave, NZ6D, he was a huge help in the early days. His technical chops were awesome. He gave so much benefit to all of the stuff we're doing, and we still miss him a lot. We've got Michael and Chris, and it seems like we've got a lot of Daves here. I'm not sure what the reason for this many Daves. Dave K5HC, unfortunately, he moved to Texas, and so his help kind of dwindled after that. He was a huge help when I was debugging the first firmware for the Zoom spot for D-Star. Yes, and I have just been corrected. It's AA4 CD, not 5 CD. I can't type. Thank you, Chris. And then Dave Hall down there at the bottom with his early work with the MMDVM stuff and creating those tremendous how-to documents. I don't remember the total number of pages, but it was something crazy, like 120 pages of documentation. So all of these people, their work starts from the very beginning of these hotspots and these repeater boards all the way through MMDVM, and there's still help in testing. So I'm going to talk a little bit about some of the earliest stuff. Some of you may remember seeing some of these boards. The first thing what we did was an AMBE 2000 dongle, which was just a plug-in dongle similar to that original blue dongle that Mo Wheatley manufactured. I think they called it a DV dongle. I don't have any pictures. I can't find the full schematics anymore. I can't find the PCBs. I don't know where it's all gone. It's lost forever. The next thing is that wonderful picture in the top left, which was the Arduino-based board and using the hardware. Up to this point, all of the hotspots, all of the repeater boards were closed source. And I wasn't fond of that idea. So I decided to try and duplicate much of that circuitry quickly, write some quick firmware for an Arduino and see if it was feasible to put a full repeater in an Arduino. And it turned out it was. And so I started working on that. I made the first software open source on GitHub, and it got attention of a number of people who helped. The next one, the middle top picture, is the first Raspberry Pi repeater board, and it has the Arduino chip in the middle and the demodulator chip, all on the same board. This worked pretty well. It was used for quite a few people for hotspots. We then had an Arduino-based board that the top right picture there is the evaluation board for the 7021 chip. We bought a whole bunch of those over a period of a year or so, and we needed to add the Arduino code to sit between the Raspberry Pi and that board, and quite a few members had those as hotspots. I still have 2 or 3 of them sitting in my garage. The bottom left is that same eval board. It's a similar eval board made by a Chinese company, still the 7021 based thing. It is jumper wired to an STM32 board, which is fondly known as the blue pill board. I ported all of the code over from the Arduino to that board, and that was the basis of the very first STM32 based hotspot for MMDVM. This is the board that I sent to Andy in Chile, and he's a huge part of why we have MMDVM. The bottom middle picture is the ZUMspot Libra, which is the very first board we did that used the same eval board from China, the same blue spot pill, the interface connectors, and so on. And it was through-hole solderable so that pretty much any hand could put them together. We manufactured, I don't know, maybe 100 of those. It was the beginning of the real ramp up of the excitement for MMDVM. I think I still have one of those boards in the garage. I keep talking about MMDVM. It's multi-mode digital voice modem. In 2015, Jonathan was thinking about what to do with his spare time, considering he was working contract job a long way from home. So he would drive to his job on Monday morning, spend Monday, Tuesday, Wednesday, Thursday night in a little flat, and then drive back home on Friday night. And those nights where he's in the flat, he got bored, so he wanted to do stuff. And prior to that, he had produced some software for D-Star that ran on a PC that let you use a USB sound card connected to a real radio. In my case, I tested mine with a Yaesu 7900, and it gave you an ICOM radio with no ICOM electronics. And he posted in the Yahoo group that he thought it might be possible to do the DSP and support multiple modes, not just D-Star. And I give him a lot of credit for his early work, and I thought about what he was doing, and he asked for someone to create a modem, to create the hardware for him, and I declined to participate. I didn't think it was really feasible. I didn't think there was enough people who would be interested in, so I declined to help him out. And I slept on it, and then the next morning I woke up and I said, you know, Jonathan's smarter than me in this DSP stuff. I think he might be onto something. So I created a modem, sent it over, did the firmware for it, for the low level firmware for the modem, sent it over to him. And then I'm just going to skip forward just to get to the modem board, but this is the modem board that I put together. It was basis of an old Arduino design that I had done. And I did the design of a modem, made the modifications to the PCB, got it working, sent it to Jonathan. And about 3 days later, he had the first D-Star going on that modem as part of his MMDVM stuff. In the meantime, I built up another modem, got it working. He sent me the firmware up. And at that point, there were the first 2 MMDVM repeaters going, one in my house and one in his. Our last count, we think there may be well over 100,000 people worldwide using MMDVM now. It's become possibly one of the very most successful amateur radio projects there's ever been. And I want to make sure I point out right now, Andy in Chile, MMDVM would not be where it is without Andy's help. He did incredible amounts of work on the firmware. When I sent him the first modem, he had DMR added in a couple weeks. A couple weeks after that, he had P25. A week after that, he had NXDN. He was very prolific with his work, and it's been a huge help. I want to talk a little bit about MMDVM, where we are kind of at the moment. It supports D-Star, DMR Fusion, P25, NXDN, M17, FM, and POCSAG. It's a lot of different modes, all supported, and everything is open source for the software. There's a successful groups.io group where people discuss things. And just to take a look at the Brandmeister network last month, at that particular moment in time, where I took that screenshot as an example, there were 16,000 hotspots online and being used. That's an incredible number, and that doesn't count the people who are offline. That doesn't count the people who are doing P25 or D-Star or any of the other modes. It's amazing how successful it has become. I also want to talk about Pi-Star, because Andy Taylor in the UK has been a huge part of the success of MMDVM. Prior to Andy starting work, there were some hotspot user interfaces produced. They were needed, they were great at the time, but Andy really stepped up and produced this, and it's really become the de facto standard that everybody uses to interface to their MMDVM hotspots. And all of his software is open source, and he keeps it up on GitHub. Andy has become a bit tired of maintaining, so he has not made a lot of changes as late. But there are other people who have forked Pi-Star and are doing lots of cool new things, and I look forward to seeing where those go. If we want to talk about the kind of the progression of the modems that are used for the repeaters, I talked briefly about this left picture, which is the very first D-Star modem for MMDVM. It plugged into an Arduino Due board, which was an ARM-based processor, which was a huge step up from the old Arduino chips we'd been using before. You will see that this picture, I think, is from a Papa member, where you have the modem board plugged into the Arduino Due, connected by USB to a Raspberry Pi, and that was your repeater. Going on, and that white board was the second generation board with new filters, 2 op amps in each direction, and an improvement in quality, and really an improvement in the range of radios that were supported. The third and fourth pictures are essentially the same circuitry. The third picture is what a lot of people are using. This is what we use on the Papa Hilltops for all of the MMDVM machines. It's the latest version. It has an ARM processor that is approaching the same horsepower that the original Raspberry Pi had. We've got huge amounts of computing power in there to do things in the future. A huge amount of work has gone into the radio interface circuitry to make sure it works with the widest range of radios. It works easily. And the last one is just the same circuitry, but done to allow you to plug that into a Nucleo board instead of a Pi. If you didn't necessarily want to do the work and put your Hilltop on a Pi, wanted to use it on a more powerful computer. I should have done some work earlier and gotten better pictures, but this is the picture from last night of the Papa Hilltops that are currently multi-mode. I'll have to get the other guys who know more than me, because I can't keep up with other Hilltops if they are also using MMDVM. I know that we are in the process of trying to retire a lot of the D-Star equipment, which is now approaching 15 years old, and hopefully that will be accelerating. But we're using a lot of MMDVM boards for the Hilltops, and a lot of other clubs are doing the same. The Zoom Spot. The Zoom Spot is the low power 10 milliwatt repeater. We saw some pictures of the early versions of it. These pictures are more what people recognize now. The one on the left is the Pi Zero sized board. That was the original one introduced in 2017 or late 2016. I can't remember now. It's still a very popular board, and a lot of people are using them. An even larger number of people are using the Chinese knockoffs. The one in the middle is the Zoom Spot USB. That's the older version. They are boards that were out of production for a long time because I couldn't buy parts. I now can get parts, so the new ones look like this. They no longer have an external antenna. They have a fairly advanced PCB-based antenna that actually works better than the external antenna. And then right is the Elite, which is the version that uses the 3.5-inch LCD screen. It's Pi 4 based, so you've got lots of performance, and it's not as slow as the Pi Zero based. Again, another part of open source is the guys who did the tremendous work early on with the next-gen screens, writing the software to support MMDVM. And those early ones were also open source based, so that everyone could figure out how it was done. It all goes back to Bruce up in Montreal sending one of these next-gen screens to Jonathan saying, you might want to take a look at this. And Jonathan found it very interesting and added in the support for the initial screens. Cool new stuff. We've got so many people working on this thing. There's probably half a dozen other things that people have worked on that I have no knowledge of. But Sean in China modified the code so that for his, we didn't get it, unfortunately didn't all get released and then get merged into the project, but he has it so that when it boots up, it gives you a QR code for the URL to get to the Pi Star setup screen. And he also seems to have fixed the annoyance of putting the wireless LAN address in number form on the screen when it boots up first time. That still needs some work. Another one, Roger down in VK land, as part of the OpenGD77 program and project, they've set up that radio, which is an old radio oddity radio, with new firmware, and have it connect by USB into a Raspberry Pi, or in this case, I think it's like a Nano Pi. And it acts as a 5-watt hotspot. All open source. A lot of really cool work done there. There's some other new things that are in progress. I released up on GitHub a project to use the M5 stack so that the screens look very similar to the next-gen screens. All that code is up on GitHub. And it uses the same protocol that the regular next-gen screens do. So that if you wanted to make some cool stuff, these screens come with Bluetooth. They're ESP32 based, so they come with Bluetooth and Ethernet. Sorry, not Ether, Wi-Fi. And so in theory, and we'll talk about this something else here in a minute, in theory, any IP-based connections that you have could also be getting these screen updates and updates from what's going on, like call signs, country name flags, so on. Community support. GitHub is where a huge part of all the software is kept. There are there've been regular releases. They've kind of slowed down now because the project has matured a long way. There's the groups.io group, where everyone who's anybody in the developing world is in there and helping answer questions. I have to give a shout out to Toshin, who's up in Colorado. He spent his career writing technical documentation and then wrote up a great set of instructions on how to set up and maintain your Pi-Star and thing. He still updates it. He still keeps his website and the PDF current. He's always doing a lot of cool stuff. I'll do my plug, which is one thing I always do, which is we always want people to help develop software. We're always looking for testers, and testers are a lot easier to find, but we're always looking for people who want to help us develop. And that's something that we're always asking for help and looking for new blood into the system. Some other things that are going on. There is a weather balloon crossband repeater that has been developed. The software has been written by Papa member Phil, KA9Q. It is based on a radio transceiver board that David and I designed. And it also uses an SDR for the receive side. And what makes this interesting is that he's basically set it up so that he listens on 6 separate FM channels at the same time and takes the audio from all 6 and mixes them into a single repeated signal that comes back down to the ground on a single FM channel. And it's crossband, so that we avoid a lot of the interference problems at the balloon side, because we want to try to minimize the mass that we're lifting. And the goal is to try and fly one of these this spring. AMSAT has put in a request quite a while ago for us to try to come up with one that we could fly that would try to make it across the country and have a coordinated event where we let people across the entire country know that it's coming, publish the projected paths, the current location, and allow them to talk to one another as it crosses the country. We'll have to figure that out. Right now, our balloon group here in San Diego has been holding off launching any round the world balloons till the world political environment gets a little more calm. We're going to do a pop and drop tomorrow and have it go up nearly 100,000 feet and then try to have it come back down in the desert. So we're still okay, we think, doing the up and down balloons, but we're going to hold off on the round the world ones. I mentioned briefly earlier the MMDVM Pi board for Nucleo. Well, this is a combined project that uses the Nucleo MMDVM board on a host board and a ST micro evaluation board, that white little thin board on the right hand side, and then using that in conjunction with the Mobile Link D open source TNC software that has also been made available on GitHub. So the PCB, the holder PCB on the right, is available to anybody who wants to download it from Mosh Park. The design for that is available open source. And so you get the best of both worlds. One is that you get the really tremendous work that the Mobile Link D guys have been doing on the DSP code. But you also get the added benefit of the years of development of the radio interface circuitry. And you can buy stuff directly from the Mobile Link D guys, but I'm not sure that their radio interface stuff is as robust as what we have as part of the open source stuff. But again, it's another part of open source, another part of repeating, and so on. I'm going to talk about some stuff that we're planning. This is kind of the future stuff. Michael and I have been working very hard on trying to prepare for this. For those of you who use MMDVM, there are some issues with the way you get configuration data. There's issues with the way you get status updates. For example, in order to get the last heard information, the Pi-Star software has to sit there and constantly monitor a log file, a text log file. And when you do that, it's chewing up resources, it's slow, it's cumbersome, and so on. So we had proposed MQTT as upgrades as part of the display code to do some things that Jonathan had asked for. But fairly recently, Jonathan announced that he wanted to try and put the status code through MQTT. Basically, MQTT is a software system that you run on a platform, and in this case, we probably run it on the Pi, and it's listening to internet traffic, and in this case, local internet traffic, so that you have a publisher who sends something to the broker, and then you have a number of subscribers who listen. So what would happen is MMDVM host would be the publisher. It would send status updates like call signs and other things like that to the broker. And then you would have a separate little process running on the Pi that's listening for those packets and then just publishing those in the last heard list. So gone are all the extra amounts of effort of parsing log files and doing all this other stuff. You can just tell the broker what kind of messages you want to hear. And so when there's messages going to the broker that have nothing to do with you, you never have to worry about them. What we envision with this MQTT stuff is that because this is IP-based, a subscriber wouldn't necessarily have to be your local machine. So we could have a broker sitting on a hilltop, and the subscriber could be someone's desktop at home getting status updates from all the under the hood stuff that's going on of an MMDVM repeater on a hilltop. All standards based, all done cleanly and efficiently. And we're very excited about the ability to do this. And I'm very happy to hear that Jonathan is interested in doing this as well. Yeah, and I just finished kind of talking about this multiple connections, meaning, multiple subscribers, meaning the way things are done now with MMDVM, if you have a next-gen screen, you can only get your updates on the next-gen screen. If you also had like an OLED screen or a CFL screen and you wanted information on that as well, there's no real mechanism to have more than one listener. So in the case of MQTT, you can have multiple subscribers and a driver for each one of those screens and different kinds of information on each screen. Kind of wrapping up here. So in the more recent ICOM radios, I guess I should update this to include the 52, you can use the radio via USB and an incredibly overpriced USB cable from ICOM to use that as a 5-watt D-Star hotspot and use it in terminal mode. Pretty cool stuff. It's awesome that ICOM is doing this. And it's similar to the GD77 project that I talked about earlier, but it's another piece that at least ICOM is doing some things to embrace what we're doing in MMDVM. And there's one more thing here that I wanted to talk about. Some of the open source crossover from things we're doing in MMDVM is one of my other passions here is helping develop the AMSAT CubeSat simulator. And it is pretty mature right now. And you can most of the time order the parts from directly from AMSAT. It was done as a project for education, trying to help places where students are interested in space, are interested in satellites, interested in CubeSats, without the huge cost of developing a CubeSat or the huge commitment in time. And usually in most cases, it's years of time to develop it. We wanted something that could go into a classroom and they could be transmitting data in minutes. And that's a huge part of keeping the students interested. The precursor to this was something I presented at a small satellite conference, a bunch of years ago now. I was up there with Bob Twiggs, and we were talking about trying to get students interested. And he asked the room, and there might have been 1,000 people in the room, and he asked them, how many are students? And there might have been 200, 250 students. And then he said, how many of you are working on CubeSats? And virtually everyone put their hand up. And then he said, how many of you have actually got to the point of transmitting data? And there were maybe 5. So there's a huge opportunity to get students interested and get them with something functioning, because some of these students will never see their satellite fly while they're in the class. They'll be graduated before they fly. So there's a lot of open source for this, again, all on GitHub. And some of the basics of the CubeSat simulator come from early things we learned and did in the MMDVM project. So that's kind of where we are. I've kind of had 40 minutes. I've kind of been talking for a long time. I'm open to questions, comments. If you want to let me know if you have anything you want to cover.
Thank you, Jim and Michael. Jim mentioned that Papa is transitioning the D-Star repeaters that are native D-Star repeaters. These are 30-year-old repeaters that are beginning to fail and were low performance RF hardware in the first place. So we're using Jim's MMDVM in D-Star mode. And this is something that Michael and I did yesterday. I don't know how clear this is, but so this is on a 19-inch rec shelf. So this is the way that the Papa sites implement the MMDVM for our multi-mode and single mode digital radios. And this shelf has, this is the MMDVM in here. So there's a Pi 4 and Jim's MMDVM board. And this over here, let's see, right here, is a voltage converter that takes the 12 volts that's available at the site and converts it to the 5 volts to run the Pi and the MMDVM. And then on the back, there's a standard radio interface connector that we use to interface to the actual radio hardware. whether that, some version of MTR 2000, SLR 5700, or CDM tray from Motorola. Jim's board and built these digital interfaces for our radio systems on the Hill. And depending on the site, this one is D-Star only. Some of them are D-Star and P25, depending on what the site is. So
and
just wanted to share that
Who's talking now?
we're implementing this pretty quickly. Thanks, Jim.
Yeah, so Chris, I was going to make one other comment, is that the goal here is to try to come up with a standard platform that we use for as standardized as we can make it for all hilltops, so that we can,
Correct.
when something fails, we can just take the spare and truck it up with a software update.
Right, and that's what this shelf represents. So this is the standard, and depending on what the radio is, for example, in this case, this is going to Santiago, and the radio up there is an SLR 5700, and its accessory connector provides 12 volts. So in this case, this is wired to use the 12 volts that comes off of the SLR and feed the converter. In other instances, this would be open, and the 12 volts at the site that fed everything else would then feed this tray and power up the MMDVM. So it's just a matter of repositioning the wires on the terminal strip, depending on what the RF hardware is.
And Chris, do you want to talk just briefly about the radios that we're using?
So in the cases of D-Star repeaters that were native D-Star repeaters, we are replacing them with the Motorola SLR 5700, which is a 1RU 50 watt Motorola repeater. That repeater natively does DMR and analog. When we're using it in the D-Star configuration with the external modem, so the Motorola SLR 5700 has its own internal DMR modem. But when we use it as a D-Star, we use the external modem and use it as an analog repeater, if you will. We also use that same repeater as an analog repeater at other sites and in its native DMR form at sites that have DMR. And then at other sites, we were experimenting with this using running it at P25 mode. And it wasn't working very well. And what Jim and I determined was that even though the SLR 5700 has an analog input and output on the system connector on the rear, that analog input and that analog output are digitally sampled internally and then fed to the modulator, and also from the demodulator is digital IQ. And what we found was that the timing of that particular sampling was not coincident enough with P25 sample rate. So we were getting a lot of data errors. So what we've been doing now is building P25 repeaters either out of an MTR 2000 or a combination of a receiver and transmitter from a Motorola CDM mobile radio. And we've eliminated those sampling problems that were introducing error into our P25. But for D-Star, they work great into the SLR. We don't have any problem with GMSK, just with 4FSK or C4FM, which is what P25 is.
So Jim, we did get a couple of questions here.
I see them here, yeah.
Okay.
So Cecil gave me a hard time about, I'm going to talk about one more thing real quick before. So Cecil gave me a hard time about hearing about something new that we'd been working on, finding out about it, not directly from me, but finding out about it in the wild or from our Instagram or something. And so what I was going to point out was HRO had asked us to develop a smart cat screen. So this is the one for Yaesu. Right now it's paired to my 710. So it's it updates in real time all the information that's on the screen of the 710. Right now it's running on battery and it's running on Bluetooth, so there's no wires at all for it. There's also a screen which I can't show right at the moment, which does the same thing for ICOM radios. So Cecil gave me a hard time because I didn't tell him about that before I made the announcement, because we'd normally made announcements to PAPA members before on every other new product. Yeah, and these screens will be available through HRO. We're hoping to have them in their hands in early May. So yeah, we're looking forward to doing that soon. So the first question here is, please talk a bit about mobile hotspot operation within and without our repeater system. So hotspots, if they're MMDVM based hotspots, so the little ones that are, you know, based on a board like this, those will connect, plug into a Pi, and then you pair your Pi to your internet. Like if you've got a MiFi or you've got it pairing to your phone, that connects to the internet, and then it behaves just like it would at home. You've got an internet connection and it can talk. So you can connect to the Papa Reflector 12 if you're on D-Star, or the Papa talk DMR talk group, or the Papa P25 talk group, any of those things. Chris and Mike, you may have to answer my question for me. I don't remember whether Papa allows direct hotspot connections to repeaters in D-Star or not. I can't remember whether.
Yeah, so I can talk on that. So we don't allow connections directly to repeaters, but we do have a hub set up. And for members, the All-Star node ID is 49171, and for non-members, it's 49172. Now we've got a process that runs daily that looks up all the node numbers and compares that to our member list. And if it finds any call signs that match between the two, it automatically adds them so they can access 49171. So members don't have to do any kind of registration to get access to that.
Right. So that means that as long as you've got an internet connection and you're using a hotspot, it's just like being at home. You can connect to the world, or you can connect to your local groups. As Michael said, there's restrictions on getting directly to a repeater, but most of those repeaters are connected to something that you can get to. There's always this question of how much bandwidth can we support getting to a hilltop, because every person that's connected to a repeater is another copy of the same data getting passed around. And if that covers your question, great. If not, just put a follow-up in there. Second question, is there any D-Star functionality that is lost by using MMDVM and Motorola for D-Star? And if so, what functionality is lost? The answer is yes, there is some functionality lost. It means we're not running the ICOM G3 or G4, whatever the latest version software is. So there's some functionality there that we don't get. I don't know that I've ever heard anyone say ever that they missed ICOM functionality when they were running MMDVM. It's all D+ based. It's all well supported. It goes into the reflectors, and the reflectors aren't ICOM either. Those are based on Robin's work. So I don't know that we miss any functionality. I don't think there's any functionality that we actually miss that's not there. When we use the MMDVM modem and the Motorola radios for D-Star, we have got a much better electronic solution than we ever had with the ICOM things. The original ICOM repeaters were just a pair of IC800 mobile radios in a box, and things have come a long way since then. And those Motorola radios are really nice radios, and the modems are pretty decent too. I think the modems do a better job with the software DSP than the old hardware modulator demodulator chip. Next question is, what is the remote screen product going to be called? That is a great question, because it's an HRO commissioned thing, so I'm not sure. It'll be something like Smart Cat for M5 stack or something like that, because we're going to try and support for Yaesu the 710, the 991, and the DX10, and then for ICOM the 70, 300, 9700, 7610, and 705. And the hope is that we do them all by Bluetooth. For the radios that have Bluetooth, we use it natively. If it's an ICOM radio, then we have a CIV adapter that will plug in to your back of your radio to give you the Bluetooth capability. Mobile connections via All-Star works very well, is another comment here. At some point, I need to spend some time and do some playing with All-Star. So
Yes, you probably should. And then we can add it to the analog support on MMDVM software.
yeah, you know, the hardware for the MMDVM Pi would allow All-Star Link to be done on it. It just needs someone to do the firmware.
Okay. So there you go. Developers, hop to it.
Yeah. So we're now past our hour point. I have covered everything I had set up to talk about. I will leave it back, hand it back to you and Cecil there, Michael.
Okay. Somewhere I have a link to where the product is where the cat screen product is on the HRO website. I can never find it by searching on their site. But if I find it before the session ends, I'll post it in the chat. All right, so I guess at this point we are complete on our agenda, and I'd like to open up for general questions. So if you have a question, go ahead and either post it in the chat or unmute yourself and ask your question.
There's one more question.
Oh,
in the chat there.
Okay, go ahead.
People can continue to post questions there. Are there any firmware updates for the USB Zoom spot? The one I have no longer connects to BlueDV. It shows power but no activity. So the firmware that's shipped with is the same firmware we've always shipped. Even the most recent shipments as of a couple of weeks ago are still shipping with the same version. If it's not talking in BlueDV, send me an email offline and we'll try to figure it out. It should be, and I don't know of any software changes that are needed for BlueDV. And then there's another one which is not to me there, Michael.
All right, Jim. Thank you. I'll find your email and I'll contact you.
Yep.
Okay, thanks.
All right, so I just posted a link to the pre-order page for the cat display. They're calling it the M5 stack reservation. That's why I can probably never find it.
Yeah. They need to come up with a name for it.
Yeah.
Up to them.
Okay. So Robin, on your question, so WRT, I'm sorry, I don't recognize that.
With respect to.
What does that mean?
It's
With respect to it, in other words, are we supporting any particular vendors or any particular recommendations or hotspots to stay away from based on the experience of the group?
Or digital or analog?
Digital.
Well, Zoom spots are the obvious recommendation. The open spot is a fine product. And we've got a number of members that use those and they work fine. And the only thing I'd caution about is if you're going to buy something that's kind of a no-name Chinese or a no-name brand, I won't limit it to Chinese. Just make sure you check reviews and make sure that you understand what you're getting, because some of them are still based on original designs that Jim did years ago, and they're not necessarily the greatest quality or implementations of those designs. So like I said, just think about that. And somebody asked where I posted the cat display link. It's here in the chat. Oh, except that I sent it as a direct message to somebody. So let me post that again.
Yeah. And
everyone.
I'll put on my salesman hat just briefly. The Zoom spots, the minis and the elites and so on are designed here in California. They're assembled in California. They're manufactured on the continent. They're not manufactured in Asia. There is support that speaks English in a closed time zone, and HRO stands behind them with a 1-year exchange warranty. And that's not something you get off of Amazon or eBay. So that's my, there's another question here, Michael. Please talk a little bit about management of balloons on long flights, altitude, government notification, flight control, etc. Well, yeah, that's a great question. None of us have launched new long duration balloons since the political issues, and we're not sure when we're going to fly again. I think it's high probability that at least one, if not 2 or 3 of the ones that were shot down over the US were amateurs. The one over the Aleutians is pretty, I think everybody's pretty much convinced it's from the Ham Club in Chicago. So these balloons, we can target a general altitude where they stay for the duration of the flight based on how much lifting gas we have in the mass of the balloon, the mass of the balloon, the mass of the payload, etc. And the goal we have is to try to keep them above the, I think as amateurs, we try to keep them above the normal flying altitude of commercial aircraft. For the pop and drops, which is something that gets done a lot, the FAA rules for what we're doing as amateurs don't require notification, as best we understand the rules and from our conversations with the FAA. For the balloons that are launched in the San Diego area, I've heard some comments saying that we're going to start doing NOTAMs for every flight. So it's just basically a notice to airmen that we would just fill out and submit. And because we're doing it at the school, launching from the school, we're trying to have the students actually be the ones that reach out to the FAA to do the NOTAM filings. Once it's flying, there's no control on where it goes. They go where the wind goes. The big Chinese one, it apparently had some propulsion that didn't work well, but it also has the ability to change its altitude and get into different winds, and that allows it to do some more direction finding. I mean, it's the same kind of thing you see with the passenger balloons. You know, they move their altitude up and down to try to catch the winds and move them around and direct themselves to where they land. So that's kind of it. Once it's released, once you let go of it, it's gone. There's nothing more any of us can do.
All right. Are there any other questions? All right. Cecil, did you have any last minute stuff for us?
And we have a hand up from K6AGA, Michael.
Okay.
Yeah, let me just finish and I'll wrap my portion up. Like I said, behind the scenes, we're working on resolving some of the issues, and we got a team out in the field right now trying to resolve an issue that we have with the TO repeater, and we're in the process of trying to troubleshoot that. So hopefully with a little bit of luck, we'll have the TO repeater, both of them, back up this weekend. That's about it. I want to thank everybody for their participation, both today and attending the breakfast. The breakfasts are growing numbers, and the raffles have been really success thanks to the participating partners. Let's Get Ready, Marvin, and also Kevin from Bioenos. So all of them are PAPA members. All of them have been supporting, and the results are the progress that we've been making in the last couple of years. It's just been nothing short of phenomenal. I want to thank the membership. And back to you, Michael. That's all I got for today.
All right. I'm going to go ahead and close the meeting. And